agenda for tonight. We've got really ambitious. We're going to try and run 2 separate tracks. I don't know if that will work or not. You can tell us at the end. And due to a kind of a bit of a cock-up of scheduling and logistics, we've got technical in here at 7:20, a technical presentation, and then at 7:40, the less technical presentation here. So if you want to stay on the technical track, you're going to have to move rooms, if that makes sense. Well, that's because both those presenters are remote, actually. So for whatever reasons, I won't go into details, they're choosing to present remotely using the power of Google Hangouts. So not as good as being here in person, but better than having 20 minutes silence, which was possibly the alternative. So
Well, we'll see. We'll see.
thank you. So I'm going to open just to do a bit of intro and some other bits. So we'll split at about 7, probably about 7:20, something like that, and then come back together at about 8ish. Nick's going to talk about metering project. Anyone interested in metering? Well, if you don't know if you should be, then you'll find out at that point. And then anybody else that wants to say anything quickly at the end. Yes.
Most importantly, we'll win pizza.
So that will be here. That point, if that's an incentive for the presenters to stay on track. So today, anyone on the OpenStack mailing list? It's 5 minutes past 5 today. Fulton, or 2012.2 codename Fulton, was released, went production today, which is good. For those who don't know, Fulton is the next release of OpenStack, so if you hadn't worked that out. So that was good. What that means, Fulton, some of the stats that we picked up from the blog post was 330 contributors. Anyone contributed here? Well done. Thank you. 185 new features, 1,400 bugs fixed, which is good. That's probably gone up since 5 o'clock. So, or 5 or 5. We did think about doing a what's new in Fulton session today, but we thought actually we'd wait until it was released, and of course it cunningly released just before we had the session. But it's something that we'll undoubtedly do at the next meetup. So, but a couple of the highlights. Nova Network. These either mean things to you or they don't. With a networking component, the Nova Network has now become Quantum, which is quite exciting in terms of virtualized networking support. And Nova Volume has split out to become Cinder. But again, it's quite an interesting separation of storage from Nova Volume to allow you to do some interesting things in the future, we hope. So. What I wanted to spend probably about 10 minutes talking about was the OpenStack Foundation, because that was another big thing that happened in the last month or so, wasn't it? Was it last week? Yeah. It seems like a long time ago now. It was. So the OpenStack Foundation was launched. This has this grand mission, but essentially it is there to the important words are bold, protect, to empower, and promote OpenStack. As you'll know, there's lots of people very interested in OpenStack now. Contributing towards it, as we see, lots of companies getting involved in developing it and deploying clouds on it. So I think there was certainly early on in the project, some uncertainty or perhaps apprehension about how it was going to be controlled and maintained and governance of it. And the OpenStack Foundation was launched to try and answer those questions that were being asked of it. So that was a big thing a couple of weeks ago. We see how it all came about, as is the way in these things. The discussions about having an independent foundation to govern this started a year ago, and then work went on in terms of creating the frameworks and companies getting on board. Then all the legal people got involved, and 6 months or so passed, and we're here today. So with a number of people signed up. The approach is to kind of, as it says, provide a home for OpenStack. So and preserve, I guess, some of the qualities that have made it so successful. that have made it so popular today. And a lot of that is having technical people making decisions based on technical merit, not necessarily on the interest of any one given company, for example, or customer for that matter. Kind of ring fencing resources to build community in the ecosystem and other bits and pieces, as a whole. Again, not at the direction of any one company, and ensuring that there's lots of people involved in it who can make money and therefore continue to be involved in it. Making money, but still to be seen, I guess. So there's kind of the three main pillars of this. Tech committee, 13 total members, 8 of those are project leads, 5 are direct elects, either elected by other contributors. Anyone know? Anyone know? No? Okay. There's the board of directors, which is 24 people. I think there's another slide on that, so I won't go into too much detail. And then there's the user committee, which is getting bigger all the time. Lots of people getting involved in that. I'm guessing some of you, I won't ask the question, many of you are probably on the user committee in some way, shape or form. 3 types of members, individuals. Anyone here? Yep. Okay, good. So these are people who are just out there to promote OpenStack, pick it up, and ensure it's doing the right thing. They also have, I guess, obligations or duties to vote and can also run for leadership positions. Then you have platinum members. These are the companies that have basically put a lot on the line, so invested large amounts of time, money, and people into creating OpenStack and furthering it. And there are 8 of those, if I remember right. Yes, 8 of those. I won't read them out. You can see it. Who have some been in since the beginning, some to come in a bit later, but all heavily invested in it. And then you've got the gold members, and these are there can only be 8 of these, by the way. So you won't get another one until somebody drops out, if that makes sense. And then you've got the gold members, who are the people that were either too late to become platinum members, or aren't prepared to make the right level of investment when they could have. So there we go. I'll skip through it in the interest of time. Board of directors. So these are, as I say, made up of the platinum, gold, and individual members who are voted on. So they are basically there to guide things, set the overall budget and goals for it. Individual members elect 1/3 of the seats.
Was it ever announced who got elected by the individual members? Because I voted in the election and then didn't see an email saying who had got elected.
Yeah, it was announced.
I just missed it.
You weren't paying close attention.
Yeah, but
Okay. Platinum members appoint 1/3 of the seats, and then the gold members elected 1/3 of the seats. And it's again, it's quite interesting actually. Some of those discussions that go on some publicly, some behind doors, asking, should we let them in? So, which is all good. There's a code of conduct for that about committing and advancing OpenStack, as you can read yourself. And importantly, no one company may control more than 2 board seats. Right?
Which was actually interesting because one company, they couldn't have, they were voted to have more than 1 seat, but they had to
give one up.
Yeah.
How do they determine who got the seat? Is it
Rock, paper, scissors.
arm wrestling? If only it was that good, that would be great. So a number of technical leads. How many of those? Was it 6 or 7 or something like that? Was it 8? Was it? Thank you, yeah. So manage the day-to-day operations of the projects, driving those, ensuring that things are moving on in the right way. Each OpenStack project, core project, has to have a project lead, obviously. And it's a 6-month term, so sentence. I think I'll probably move through that unless anybody has a particular interest in it. Technical committee, guiding the policies across projects, I guess is probably the simplest answer. They are, again, elected. You'll see that as a common thread. The only people who aren't really elected are the platinum members.
I think one thing that should be said about the tech committees, only active contributors can participate in the election for tech committees, either directly or indirectly through projects, while the other instance representing OpenStack members you don't need to actually contribute code in order to be able to vote.
Good point, thank you, mate. Yeah, I think that's probably the most important thing. The user committee, obviously the user base is growing significantly, but we need structure to help be determined on that. So there's already some people on board, but I guess looking for input on that. And yeah, a lot of these things are kind of, well, they have been established, but are still being developed. So some of the promotion of the OpenStack stuff independently is still coming on. A lot of the legal stuff has been done. Event management is a big part of actually the OpenStack Design Summit, and other bits and pieces. So, which is actually in a couple of weeks.
One thing to note is that thanks to the contribution of the gold and platinum member, the foundation has a very nice operational budget. I think it's something around 3 or 4 million a year.
Yeah, there's quite a bit of money in that.
A poor foundation.
Good. So, in kind of summary, the priorities to grow the adoption globally across all industries, not just service providers or public cloud providers. Enable the ecosystem to tools vendors and deliver the best cloud software. That's which one over here. So, any questions at all? No. About Folsom either? Good, because I probably wouldn't be able to answer them. So, in that case, we will do. I'm hoping that we're going to have somebody online. He's not there. Oh, yes, he is. There we are. So, in this room, we'll be having John Garbutt from Citrix, who's going to be talking about Zen and their role in OpenStack. And so, who was here last time? So last time we had everything you ever wanted to know about KVM and OpenStack. This time we've got everything you wanted to know about Zen and OpenStack. So kind of. So that was a very probably poor description of the presentation that you gave. But we thought, in the interest of balancing yin and yang, we'll have the Zen piece. But going on in the room next door, and I'll point, it's actually just across that way. You'll see it because it's got the sign on. It's going over the door. We'll be having James. Where's James? There we are. James Pace is going to be talking about, if I've got this right, hope I got it right, talking about improving quality. See that one? There we are. Automating OpenStack testing, which is really about how we continuously improve the quality of OpenStack and why that's important. So, make your choice where you want to be. Good. I'll turn the camera around so you can see who you're talking to.
Awesome.
There's about 230 odd people.
You're missing the guys up.
Yeah, there's missing the guys upstairs in the balcony, but no.
Oh.
Good. There we go.
Cool.
Excellent. So I'm going to run through to the other room. So I'll leave you to crack on, but I shall be back intermittently every so often. So if there's any problems, give me a shout.
Cool.
Good.
Thanks. Hi everyone. Sorry I couldn't be down there. Actually, just before I start, I don't think I can actually hear any of you that well because the mic's so far away from you guys. So if someone wants to question, do sort of shout. I'm not trying to be rude by ignoring you. Cool. So, can you all hear me okay?
Yeah.
Awesome. I can vaguely hear you. This is good. So, I'm John Garbutt. I'm now leading up the OpenStack effort for Citrix. I started working on OpenStack back in November, December sort of time, 2010. Originally working on the Olympus project and bits and pieces around that. So I just wanted to sort of introduce Zen server and OpenStack and how they work together. So I'm just going to bring this back up. I just want to do a quick survey. Have any of you played with Zen before at all? Cool. Have any of you played with Zen and OpenStack yet? Cool, okay. We should try fix this. Excellent, so I'll get cracking. So I guess the first thing to say is I'm a Citrix guy, I'm talking about OpenStack. What's all that about? So Citrix is doing a lot of work with CloudStack after we bought cloud.com and sort of integrated them into Citrix, but there's still 3 of us working full-time on OpenStack. The kind of things we're doing is I'm spending most of my time doing some automated QA on with the different configurations of OpenStack and Zen Server, hoping to get that reporting into Gerrit as soon as it's stable and we've got the Gerrit integration stable. We're doing some features. Then in Folsom, there's live migration using local storage, using a new feature called Zen Motion inside Zen Server, which is quite cool. So live migration without the need of using shared storage from local disk to local disk. We've done some work helping with the feature parity gap with KVM. So there's an awful lot more things. Well, the things we added in Folsom were boot from volume and these kind of bits and pieces. Okie dokie. So if my screen, hang on, sorry, my screen's gone blank. That's not good.
We can see that, so that's good.
Okay.
Oh, that's good.
There we go. So I was going to just quickly talk about Zen, although I'm guessing some of you are converts already that have used Zen. For those of you who don't know, Zen came out of Cambridge University as a project, and part of the Xena server project. Zen was a component of that. And lots of things have happened. Rackspace started using Zen with SliceHost. Amazon are using Zen in EC2. Rackspace Cloud has moved across to Zen Server. And the Zen Server product itself, not long after Citrix acquired ZenSource, who originally built Zen Server, Zen Server is open sourced as the XCP project, which you may or may not have heard about. So I sort of looked back in the papers from Cambridge University, and it was interesting to see that Zen was, you could almost say, was designed for the cloud. So it was designed from the beginning for running in parallel untrusted workloads. And in fact, the Xena Servers project was looking at distributing compute across the globe and how you could do that and what abstraction you could give to developers to enable that to happen. So why use Zen today? It's got a huge open source community behind it. It's not always the loudest community right now, but there's certainly a good number of people there. And there's the Zen Summit conference that was co-hosted with LinuxCon was quite heavily attended. It had sort of 2 tracks of conference over a couple of days, and it was interesting to see all the innovation that's happening on Zen. It certainly seems to have picked up in the last year or 2. So I want to say, Zen's quite a proven, you could call it cloud proven. Don't really want to overuse the word cloud as such, but it's used by Amazon and Rackspace today and used by many others. There's been efforts to count how many people are using Zen, and it's tricky because it's one of these packages that's available in many different distros. But estimates are certainly around the 10 million mark of users. So I wanted to highlight, why Zen rather than some of the other hypervisors. So I just wanted to point out it's a Type 1 hypervisor, which was designed particularly for the idea of providing good separation. I'm not sure if you can see my cursor, but on the left you can see this the Type 1 hypervisor, which is basically you have this thin layer on top of your hardware, and that subdivides up, effectively scheduling operating systems onto the hardware. Now what Zen did is it had sort of this hybrid version of a Type 1 hypervisor where you make the hypervisor thin, so the hypervisor doesn't have to have drivers. So Zen actually is reusing relatively standard Linux drivers rather than having to write all its own drivers. So it's not quite a pure Type 1, it's a slightly modified Type 1. And the alternative is where you have sort of you're inside the operating system, so you have to trust the whole operating system does some of the separation. But there's some interesting things you can read about this. Just wanted to point that out. Okay. So before I go any further into this, one of the confusing things I think when you start to use, look at using Zen with OpenStack is all the different terminology around this. So I just wanted to try and do a very quick summary. So just to be clear, Zen is this very small, thin layer that sits on top of the hardware. It's called virtual machine monitor, something, one way of talking about it. And then you probably hear people talking about Zappy and Zen API. Well, these are the Zen API is the tool stack built by Citrix for the Zen server system. So this is a XML RPC API that allows you to manage your Zen hypervisor. That's the thing that lets you start the VMs, manage the networks, manage the storage. And it's got a daemon called Zappy. And one thing I didn't point out with the concept of the type 1 hypervisor is that you have the concept of a trusted and an untrusted VM. So this trusted VM has special privileges that allows it to access the hardware. Traditionally in Zen, you just have a single DOM0 that has privilege to manage the hardware. More recent versions of Zen, you can actually slice this up, allowing you to get better performance and better isolation in certain cases. We'll cover a little bit more of that later. And then every other VM that isn't part of this management infrastructure is a DOM-U. It's a standard guest VM, and they're considered untrusted. Okay, so has anyone got any questions about Zen versus Zappy and all that kind of thing? Does that sort of make sense? Excellent. Cool. I can see thumbs. This is nice. Okay, so the next thing I wanted to cover is I just wanted to sort of, if you're looking at working with Zappy, just give you a very, very brief introduction to what Zappy is all about and the concepts involved in Zappy. It's all actually really quite straightforward, as much as this diagram might seem scary. So here, for example, you've got a VM. So these are the concepts behind the API. The API is quite object-oriented in a way. So you can get lists of VMs from it, and you can get lists of hosts from it. This makes sense. So you can get information about the host, get information about the VMs on that host. On the other side of things, you've got storage repositories. So a storage repository is basically a collection of VDIs, of virtual disk images. In Zen Server, it's very often a VHD file on a local repository. So you've got file system ext with VHD files on there, and that's the virtual disk images. And those may be attached to VMs using a virtual block device. And for that VDI to actually work, it obviously has to have some physical presence in the world, and that's the physical block device. Almost identical on the network side, you've got this concept of networks. So Zen Server, at the moment at least, has there's a network per physical interface, per PIF, and then that network is sort of considered, at least on the sort of like effectively like the trunk network in terms of VLANs. Then you can have extra networks on top of that in VLANs. So it's using the Linux bridge model, basically. Obviously, each of those networks has a collection of virtual interfaces that may or may not be connected to a VM. So it's not that scary when it comes to having a look at this. That's sort of how things come about. Certainly when you look at the code, you'll see all these acronyms about the place. When you can actually get the slides from SlideShare afterwards, and there's a link to where this document is, part of the Zen Server documentation. And one of the last things I wanted to point out is what Zen API gives you beyond the standard Zen tool stacks is access to all this at a high level, including the SRs. And where the SRs become most powerful is when you have the concept of a pool. So you have this collection of Zen servers with some shared storage, and that allows you to do live migration with shared storage with the memory copying and such like. But today OpenStack doesn't make great use of the pool. You can actually create a pool in OpenStack if you install your Zen server, you install OpenStack on it in a standalone mode, then you can use the host aggregate concept with a special keyword saying hypervisor pool to actually join these together and create a pool. But frankly, you're better off looking at using the volumes, boot from volume, and using local disk where possible. So another confusion around using Zen and Zen Server is, so, what do you pick? So today there's kind of, hopefully Citrix will be able to have better messaging around this in the very near future, but today, if you want a fully open source edition of Zen Server, you can use Zen Cloud Platform. And this is all the open source parts of Zen Server, as you'd expect. Zappy, for example, is available. It's written in OCaml, and it's actually available on GitHub if you want to look at the source. The source is available for all these things. From memory, most of it's it's the GPL2 license. And what I also wanted to point out is recently in Ubuntu 12.04 and Debian Wheezy, you can now actually get XCP Zappy. So you actually get a packaging of Zen and the Zen API tool stack available within your distro. So the DOM0, basically your installed OS, you install this package and that OS becomes your DOM0. If you want to develop, it means you can actually have a desktop OS as your DOM0 with a full GUI, and then you've got VMs you're running alongside if you wish. Those who know a bit about Zen know that running X Windows in your DOM0 could be considered a bit crazy, but it's at least possible. So on the other side, we've got Citrix Zen Server, which has some extra features on top of Zen Cloud Platform today, mostly around things like workload balancing. There are matrices available to work out exactly what the differences are. This is the supported product that's heavily tested by Citrix. And this is available as a free download. There's a license activation after a few days, but it's free to do the license activation. If I remember rightly, you might have to do the activation once a year, but it is available as a free edition. And there are paid editions for extra features. As much as Citrix would hate me saying this, unless you're trying, if you want support, you're probably best using Citrix Zen Server today because you can actually buy support on that. Right now, unless you're modifying OpenStack, you won't be able to actually use any of the features of the paid editions of Zen Server. No, something we would like to fix. Before I go on, it's probably worth saying that there are two ways of using Zen within OpenStack. I've been concentrating here on using Zen with the Zen API interface. This is right now this is the most tested way of using Zen and OpenStack, because this is actually the deployment that Rackspace are using in their public cloud. They've got Zen servers with OpenStack on top using the Zen API driver. And this is the one that Citrix is certainly spending most of its time on. However, in recent months, you may have heard SUSE with their OpenStack cloud offering. And in fact, they support using Zen with libvirt on top. So using a more similar code back to the KVM case, but using libvirt to access Zen as opposed to Zen API. Okay, so I kind of beat myself to the point here. Zen API is what Rackspace, Zen API and OpenStack is what Rackspace use, and I kind of just wanted to show you what the deployment looks like. So this is using Zen Server in this particular picture. XCP looks identical. So you've got Zen underneath as ever, and you've got the DOM0, domain 0 VM. This is the packaged VM that you get as part of Zen Server. So installing Zen Server, you can use Pixie to install it, or you can just install it from the ISO, from the download. But you get the DOM0 and you get the Zen. Now when you come to use OpenStack, there are some Zen API plugins that go into DOM0 and some network isolation rules. And you need to connect your DOM0 to your management network where Zappy is. And then at the moment, you deploy all the OpenStack services in a VM. Now this may seem like an extra moving part, but it does mean that you do have a nice sort of level of separation. The Zen scheduler ensures that domain 0 and your OpenStack DOM-U get appropriate amounts of compute time, which certainly does help with certain things. And as you can see inside the OpenStack code, it uses the standard Zen API Python library to talk down to Zen API. Here I've showed it using the host internal management network. This is a bit confusing. You can access it through the standard management port just by configuring the IP address appropriately in nova.conf. In this particular case, you can see there's actually quite a lot of networks involved, but all you've got here is you've got the public network, which is where you might want your floating IP traffic on. There's a separate tenant network, which is got the VM traffic on, and then segregating all the management traffic, so your RabbitMQ traffic, MySQL traffic, and all the other bits and pieces on there. And potentially the public network, you may want, that's where you'd expose your APIs to your end users. There's some other bits. So, almost out of time, just wanted to quickly go through the last few bits and pieces. So, how can I get started? Well, if you want to develop on this stuff, if you look at the standard DevStack trunk, if you look in the tools Zen directory, you'll see a README describing what to do. But fundamentally, you install Zen server and you run DevStack with a particular local RC configuration. We've improved the documentation a little bit on this. It's still not perfect, so do ping on the main OpenStack mailing list. I'm usually listening to that, and I'll try and help through any issues that you have trying to get that going. But it'd be good to see, the more people get using it, the more we can iron out the more obvious problems in the docs. I just wanted to sort of look to the future, beyond sort of, but this is the future of Zen server and Zen a little bit. If you, this diagram is actually taken from a Citrix product called Zen Client XT, so Zen Client Extreme Edition. It's designed for where you want to have 2 VMs running that have sort of different, for different security zones. So it actually provides much better isolation than standard Zen, and it does this through using this disaggregation of DOM0. And it's also this disaggregation of the bits and pieces that allows, well, is a route to getting really good performance on some of the Neumann architectures. So where your memory is no longer local to all the CPUs, so each, you have a core, so you've got 4 cores on your box, you might have memory local to each of that. Well, you've got 4 sockets of processor on your box, and each socket may have its own local memory. You can actually ensure that each part, the control pieces in DOM0 that use shared memory with your user VMs can actually reside on the same memory as your CPU. There's some interesting work there. Okay, so where can I find out more? There's some more interesting links. You can look on the OpenStack wiki. Obviously, mail me on the mailing list. There's many other people on the mailing list with the Zen and Zen API experience that I'm sure will help you through things. And I just wanted to have some sort of open Q&A, if that's going to work correctly.
Maybe
one got a bit of tongue in cheek. Okay, so when I install my distro, there's already KVM. Don't need to install any package. Why should I install Zen?
Did you hear the question, John?
I'm afraid I couldn't.
Okay, not to worry. You might want to take your slide down so we can see you squirm as you answer.
Sure.
Thank you. The question was, if I've got KVM in my distro, and that works,
Yeah.
why should I use Zen?
I see why you want me to squirm. Excellent. It depends on what you want to do. So Zen will give you some nice separation that is likely to be better than what KVM can give you. And this, when you've got mixed workloads, I'm told that Zen is much better at scheduling the VM, so you actually get better performance when you've got a greater variety of workloads running in your VM. So in a sort of public cloud where you've got untrusted workloads, you don't know what's going in there, the Zen scheduler is sort of specific to scheduling VMs and is pretty good at doing that. Frankly, I'm not the best person to answer that question, which is a good way of sidestepping it, I know. But.
Nicely done. Any other questions? Well, thank you very much for taking time out. I know you obviously had another commitment, which...
yeah, so as you probably saw, my SlideShare name is John the Tuba Guy, and I've got a rehearsal for a concert band, and I couldn't get a depth tuba player, so I apologise for not being there.
So thank you very much for taking the time, and we'll hope to see you at the next one.
Yeah, hopefully see you all there next time.
All right, thank
Awesome.
you.
Cheers, bye-bye.
Well, you can feel free to stay on if you want to, John, if you can. Oh, there we go. Obviously not.